Yeah, hello friends. Today we discuss about memory accessing followed by physical memory organization in 8086. As you know that the 8086 contains 1 megabytes of memory, and such 1 megabytes of memory to access easily, we are going to segment into various parts like code segment, data segment, stack segment, and extra segment. And the memory is not only made with one type, it may be with RAM, ROM, EPROM, and because of various purposes like for coding purpose, for data storage, and for bootstrap program loader storage, for interrupt vector table storage. Hence, the memory may not be of a uniform type, it may be with various different types. And to access a particular memory in 1 bytes of memory, so we need to know its address. That address we call it as physical address, sometimes virtual address also. Physical address is about 20 bits, whereas the CPU contains the registers only of 16 bits. Therefore it is impossible to um, access 20-bit address to the 16 bits address. Hence, the CPU of 8086 contains a module calling it as address converter. Address converter uh, takes inputs as a base address and offset address. Based on these two, it is going to generate a physical address of 20 bits. Let us take an example here. Here, one example taken for accessing a particular uh, memory in a code segment of 1 bytes of memory. So, to access particular byte of a code segment, we require its segment address and its offset address. Segment address will be available in CS, and its offset address will be available in IP. Yeah, whatever the segment address is there, 3000H, that is going to be multiplied with 10H, nothing but 16. So when it is multiplied, it becomes 30000H. This is of 20-bit address. Plus, it is going to be added with the IP. IP nothing but 2000H. So when these two are added, we are going to get 32000H. So this is going to be of 20-bit address. This is going to be the physical address. With this address, we are going to access particular byte in the code segment. And coming to its physical memory organization, as it contains 1 megabytes, it starts from 00000H to FFFFH, 5 zeros to 5F. And this memory may be containing of RAM, ROM, EPROM, all these. And this is physically divided into two parts, calling it as even bank and odd bank. So you'll know the reason why it is divided into odd bank and even bank in the next slides. So you know that at a particular time, we can have to access only 1 byte of data, only 1 byte of data. For suppose if you want to access 2 bytes of data, so you require 2 cycles. But here we are going to organize the memory in two parts, like calling it as even bank and odd bank. And even bank can be accessed with the D0 to D7. Odd bank can be accessed through D8 to D15. Therefore, at a single cycle, we can access both bytes, one from even bank and another from the odd bank. And this odd bank and even bank can be selected based upon two signals, calling it as A0 and BHE. So because of these, we can enable either odd bank or even bank or both or none. So that you can observe in this table here. If you observe this table, when A0 is 0 and when A0 is 0, you can access 8-bit data from even bank. And when BHE bar is 0, you can access data from odd bank. When both are 0, you can access both the odd bank, both from even bank. So in this way, you can have to access either art by data or even by data or both data. So because of physical memory divided into art bank and event bank. So now we'll see how the system bus will be formed. You know that address and data are multiplexed to form A0 to 815, and address and status are multiplexed to form A16 slash S3 to A6, A19 slash S6. By using address latch enable, we can divide address data into address and data, address status into address and status. So after that, you are going to get A0 to A19 address, D0 to D15 data. And the data bus will be generally bidirectional, whereas address bus will be in a single direction from CPU to the memory or CPU to the IO. Whereas data can be to and fro from the CPU, hence it will be generally in the bidirection. And among 1 byte of memory, some part of memory is useful for storing the interrupt, and some other is reserved for some instructions. If you observe here, 0000H to 003FFH, which is useful for interrupt vector table. And whenever we reset the microprocessor, CS and IP values are loaded with the values like FFFF and 0000, so that the physical address will be started from FFFF0. Physical address is started from FFFF0. So this will be the default address whenever we restart the microprocessor or whenever we reset the microprocessor. Thank you.